let's have R on the horizontal axis, which is the frequency ratio, and the magnification factor x by delta static on the vertical axis. Now we have two parameters here to consider. We have R, the frequency ratio, and we have also the damping ratio, zeta. So I need to plot several curves for different values of zeta. So first, let's consider zeta 0. If zeta is 0, then this term is 0, and we'll end up with just 1 over 1 minus r squared, just like the previous case with the undamped system. And when r is 0, it's 1 by 1, which is simply 1. That's where the curve starts. And when r is equal to 1, become 1 divided by 0, so it will go to infinity at 1. So we start with 1, then rise up to infinity, and then drop back to 0 as r increases. Now, let's assume that we have r, this is zeta equals 0. Let's use zeta equals 0.1, for example. For zeta equals 0.1, now this term will never go to 0, so I will never have 1 divided by 0. That means my response will never go to 0, to infinity, but for small zeta, it will be 1 divided by a small number when r is 1. So the total magnitude of x divided by delta static is going to be large, but it will not be infinity. So for 0.1, it will grow, but to some maximum value, and then drop again to 0 as the ratio increases. Now, so this could be zeta 0.1. Increase zeta further, let's say 0.25. Again, the rise will be a bit smaller. Go back to 0. At 0.5, you can hardly see a little rise to 0. And as zeta increases, zeta 0.7. So adding damping will reduce this resonance effect at r equals 1. It will still be there when the damping ratio is small. Okay, you will still have a magnification above 1. The response, forced response, will be higher than if the force was statically applied to the system, but it will be a little bit limited. So adding damping to the system will improve the characteristics of the system. And one other issue is that this peak does not always, the maximum does not happen at 1 in the case of damping. It starts at 1 when zeta is 0 and shifts slightly to the left. The peaks do not always occur at 1, they're near 1, but as the damping increases, there's a shift in the position of the peak, but it's still near 1. That's where the resonance happens. You can assume that the resonance always happens at 1, because for higher frequency, for higher damping ratios, we don't have vibrations anyway. If the damping ratio is above 1, the system will be critically damped or over damped. That means we will have exponentially stable response without vibration. So we're talking about vibration in the range of zeta less than 1, and less than 1, this line is still very close to 1, so it's a safe assumption to assume that the resonance occurs at 1, whether the system is undamped or lightly damped.